Unit 4, Day 2 Notes. Right now we're going to talk a little more about the triangle sum theorem, which we hinted on last class. The triangle sum theorem again means that the angles of a triangle sum up to 180 degrees. So we're going to find the missing angles in this picture. Angles 1, 2, and 3. First and foremost, I know that angle 1 together with this angle, the 57-degree angle, are a linear pair. So together they are 180. So I know if I take 180 minus 57, I'll find angle 1. And that would give me 123 degrees. Then I can find angle 2 by combining 71 with 57 and then subtracting that from 180. So let's get started on that one. So 71 and 57 would give me 128, and then 180 minus 128 would give me 652. So 2 is 52 degrees. And now I need to find angle 3. So to find angle 3, I would take 28 and 123, add them together because they're in the same triangle. Give me 151, and then subtract that from 180, which would give me 29. So 3 is 29 degrees. All right, so you know the gist. Go ahead and do number 2 on your own. Find those angles. Pay attention to the markings on the picture, as well as there might be some vertical angle pairs as well to help you find out the angle measures. Make sure you take a picture of your completed work. Number 3, in JKL, the measure of angle J is 8n minus 6. The measure of angle K is 6n plus 10. And the measure of angle L is 5n plus 24. Solve for n and find the measure of each angle. It should have said triangle JKL. So let's draw ourselves a triangle. I apologize, the computer was acting up. Alright, so we're going to draw our triangle. Again, I apologize for the technical difficulties. Alrighty, so we were drawing triangle JKL. So let's label the vertices. And then I'm going to put the measurements inside my triangle where they belong. J is 8n minus 6. K is 6n plus 10. L is 5n plus 24. These are all angle measures, and we know the sum of the angle measures is 180. So let's add them all together and equal it to 180. So again, the measure of angle J together with the measure of angle K together with the measure of angle L is equal to 180. So that means 8n minus 6 plus 6n plus 10 plus 5n plus 24 should equal 180. And this is how we'll find n. First, let's combine all of our n terms. We have 8n, 6n, and 5n. 8 plus 6 is 14. 14 plus 5 is 19, so that's 19n. And then we're going to combine all of our constants. We have negative 6 plus 10 is a positive 4. Positive 4 plus 24 is a positive 28. And then bring down our 180. So now we're going to subtract 28 from both sides. So we have 19n is equal to 152. And divide both sides by 19. I'm guessing it'll be a decimal, but let's find out. I'm thinking of numbers that are multiples of 9 that have a 2 at the end. Eight. Sure is. So n is 8. All right. Now that I know what n is, I can find the measure of each individual angle. So angle J was 8 times n minus 6. So 8 times 8, 64. 64 minus 6 is going to give me 58. Angle K was 6 times n plus 10. 6 times 8 is 48. 48 plus 10 is 58 again. And then the measure of angle L was 5 times n plus 24. 5 times 8 is 40 plus 24 is 64. And then you can double check your math right here to make sure that we did it right and that all these angles add up to 180. So let's see. 8 and 8, 16 plus 4, that's a 0. Carry your 2. 5 and 5 is 10. 6 and 2 is 8. So yes, we did everything correct. So that was just a little more practice on the triangle sum theorem. Now we're going to talk about the exterior angle theorem. On the exterior angles, so in this illustration, angles 1, 2, and 3 are interior angles of our triangle. But angle 4 is located right outside the triangle, but it's adjacent to angle 2. Can you see, as of right now, what angle 4 is equal to? Well, you can see that angle 4 is a linear pair with angle 2, right? So you know that 180 minus the measure of angle 2 is going to give me the measure of angle 4. But let's see if you can see any other comparisons in just a second. You can see that angle 1 and angle 2 from inside the triangle fit exactly into angle 4. So we can now say the measure of angle 4 is equivalent to both the measure of angle 1 and the measure of angle 3. That is the exterior angles theorem. You take the two remote angles, add them together, and it'll equal the exterior angle of a triangle. Always, no matter which exterior angle you're looking for. The two remote meaning the angles that are not adjacent to the exterior angle. They're far away. Think of when people say, I'm going to a remote island. They want to be totally exclusive and have nobody mess with them. So the remote angles are the angles on the other sides of the triangle away from the exterior. So the two remotes added together will equal the exterior, always. That's the exterior angle theorem. All right, so number 4, we're going to find the measure of angle C. Old school method would say find this angle here, CTA. That would be a linear pair with angle STC first, and then take that angle together with the 16 and subtract it from 180 to find angle C. That's the old school method. But now that we know the exterior angles theorem, let's use it. We know that angle A and angle C are remote angles. And angle STC is an exterior angle. So we can use the exterior angles theorem. Remote plus remote equals exterior. So that means 16 plus the measure of angle C is going to equal the exterior, which is 121. So this one is going to be a little shorter. If you can remember this theorem, it could cut you some time. So why not cut us some time whenever we can? So now all I need to do is simply subtract 16 from 121, and I would have the measure of angle C. So the measure of angle C is going to be 105. 105 degrees. All right, let's go over here and find the measure of angle 1. Angle 1 in this picture is an exterior angle. 33 is a remote. 83 is also a remote. So I can use remote plus remote equals exterior. So that means 33 plus 83 equals angle 1. So 33 plus 83 is going to give us 116 degrees. And now we're going to apply the same theorem but with some algebraic expressions. Same thing still holds true. These are remote angles because they're away from the exterior angle. Remote plus remote equals exterior. So 25 plus x plus 15 is going to equal 3x minus 10. First thing I would do is combine 25 and 15 to give me 30 and bring down my x. And 3x minus 10. The next thing I would do is subtract little brother x from both sides to join him to meet big brother 3x. Which would leave me with 30 is equal to 2x minus 10. Then I would have to add 10 to both sides. Which would leave me with 40 is equal to 2x. Then divide by 2, and you get 20 is equal to x. And that's all we had to find in this problem was just x. We don't have to find the individual measures. So this concludes your notes for today.